Let's take a look at a polynomial question here from Fairfield Methodist. Given that x squared plus 2x minus 3 is a factor of the function fx equals to x power 4 plus 6x cubed plus 2ax squared plus bx minus 3a. Part A, find the value of a and of b. Now let's take a look at this one here. You are given a quadratic factor. Let's find out if we can factorize this one here. So yes, we can factorize into x plus 3x minus 1. When you can factorize this quadratic factor, you will get two linear factors. So it means these two are also factors for fx. So now what you can do is that, since I'm given the name of fx, I can call it that f, if I substitute -3, my remainder here will be 0. And if I substitute 1, remainder will be 0 as well, because they are factors. So we're going to do that two-step. So let's substitute -3 into function first. So I have -3 power 4 plus 6, -3 power 3, followed by plus 2a times -3 power 2 plus b times -3 minus 3a equals to 0. This one here, they contains all numbers. Let me type this in calculator. Let me see the value. I have a -81. Now, let's do a term add together. This is 9 times 2, that's 18, minus 3. So I have plus 15a. And this one here, I have minus 3b equals to 0. Now, I notice these are multiple of 3. Let me divide by 3 now. I have -27 plus 5a minus b equals to 0. And I'm going to rearrange so that I get b on the right hand side, and I label this is my equation number 1 by working on the first factor. Alright, so the first factor x plus 3. Now let's work on the second factor x minus 1. We're going to insert 1. So this is pretty easy, so I'm just going to do 1 power 4, which is 1. And then plus 6 times 1 power 3. So that's 6. Followed by 2a. Remember, it's 1 power 2, so I still get 2a. And I have plus b times 1, that's b, minus 3a equals to 0. Alright, so I'm just going to do it on my own because just 1. So let's see this one here. 1 plus 6 here is 7. 2a minus 3a, that's a minus a, plus b equals to 0. Let me label as 2. So what I'm going to do here, I'm ready to substitute b value at this position here. So let's substitute 1 into 2 for this b value. So I have 7 minus a minus 27 plus 5a equals to 0. This one here, insert in b position. So let's solve this one here. 27 and 7 move to the right, so it's 27 minus 7. I get 20. 5a minus a, 4a. So a value is 5. Let's substitute this into equation number 1 to get b value. I have -27 plus 5 times a is 5. 25 minus 27, so b value will be -2. So we have solved for part A of this question. Let me erase and we'll go to part B. Let's look at part B of this question here. Find the other quadratic factor of fx. Since we have gotten a and b value just now, let's just substitute a and b in. Let's see what's fx now. X power 4 plus 6x power 3. A was 5 just now, so I have plus 10x squared. B is -2, so I have minus 2x. A is 5, so here I have -15. Remember that we already have quadratic factor from the question. Let's do factorization this step. X squared plus 2x minus 3. So this line is a power 4. So if I have a quadratic factor here, I'll have another quadratic factor here. And I'm going to straight away check for x squared times x squared will give you this x power 4. So this one here, I know it must be x squared. Now let's check the constant now. So I'll have this -3 need to multiply by a +5 to give me -15. So what's in the center here? X squared term followed by x term. So I'm going to write an unknown capital kx. You can use any alphabet you like. Alright, so I have the quadratic factor pending for the x term. So let me choose another term to compare. Okay, you can compare x power 3, x power 2, or x, up to you. Now let me maybe compare x power 3. Okay, so I'm going to link this one. X times x squared is x power 3, comparing with the one above, which is 6. Right, now let's write down. This and this will give me kx cubed. When I multiply 2x and x squared here is 2x cubed. So let's add the coefficient. So I have k plus 2. These two add together must equals to coefficient x cubed above, which is 6. So k is equals to 4. Now we're ready to write down. So therefore, fx, if you factorize, you have this x squared plus 2x minus 3, followed by x squared. This is 4, so plus 4x plus 5. And if this is a factor, this is another quadratic factor, which is the other quadratic factor that the question wants you to find. Alright, so remember to conclude this as your answer in the exam. That's for part B. Now let me erase and we'll take a look at part C of this question. Part C of this question show that the equation fx equals to 0 has two real distinct roots. Now I have already equate this one equals to 0. And remember we already factorized just now. So I'm going to write again. X squared plus 2x minus 3. And our other factor just now was x squared plus 4x plus 5 equals to 0. So we don't want to do it again. It's in part B. So this quadratic factor in part A, we have already factorized again to x plus 3, x minus 1. Now what happened is that this quadratic factor can't be factorized anymore. But I'm going to show that later. So from the first factor here, the answer will lead you to x equals to -3 when you equate to 0 and solve it. Second, you will get x equals to 1 when you equate to 0 and solve it. So this one here, what I'm going to do is the discriminant b squared minus 4ac. I'm going to check the value here. Okay, so 16 minus 20, that's a -4. I'm going to explain. Discriminant less than 0. There's no real roots. When we explain the word real roots, I'm going to write this one equals to 0. Okay, it must be an equation. So x squared plus 4x plus 5 equals to 0. No real roots for the quadratic equation. Therefore, only two distinct real roots for fx equals to 0. fx equals 0 is the polynomial in power 4 equating to 0. So we only have two distinct real roots here. That's all for this question.